Have you ever wondered how different learning rates can affect your model's performance, especially when using batch norm? If so, you're in the right place. Today, we're diving into the intriguing relationship between learning rates and batch norm settings. I totally get it. It can be really confusing when you notice that changing the learning rate impacts your batch norm settings in unexpected ways. You're not alone in this. Many developers face similar challenges. Let's take a closer look at a specific case. One user recently asked, "Why does my batch norm setting behave differently with varying learning rates?" They shared their setup, mentioning that with a learning rate of 1 times 10 to the power of -3, they achieved good performance with global stats set to false during testing. But with a learning rate of 1 times 10 to the power of -4, they found better results with global stats set to true. Sound familiar? Let's explore this together. So what could be happening here? The learning rate can significantly influence how the model learns and adapts during training. When you adjust the learning rate, it can affect the stability of the batch norm statistics, leading to different performance outcomes. Let's break this down step by step. And stick around. At the end of this video, I'll share a key insight that could help you optimize your model even further. To understand the impact of the learning rate on the batch norm settings, the user should first consider how batch norm operates during training and testing. During training, batch norm normalizes the input using the batch statistics, while during testing, it uses the global statistics. Next, the user should analyze the effect of the learning rate on the model's performance. A higher learning rate, like 1,000th, may lead to faster convergence, but can also cause instability in the training process, affecting the batch norm behavior. The user should also consider the interaction between the learning rate and the batch norm settings. When using a lower learning rate, the model may benefit from the stability provided by using global statistics during testing. Finally, the user should experiment with different configurations. Testing various combinations of learning rates and batch norm settings can provide insights into how these factors influence model performance. Fun fact: did you know that the concept of learning rates was inspired by how humans learn? Just like we adjust our study habits based on what works best, models do the same with learning rates. Now let's look at the answers provided by other users. According to another user, the learning rate doesn't directly impact the parameters of the batch norm layer. In fact, Caffe sets the learning rate multiplier for batch norm's internal parameters to 0, regardless of the base learning rate or solver type. However, they point out that different learning rates can lead adjacent layers to converge at different points, which can indirectly affect how batch norm behaves. Here's the key insight I promised. Always monitor your model's performance closely when adjusting learning rates. Small changes can lead to significant differences in how well your model generalizes. And there you have it. Understanding the relationship between learning rates and batch norm settings can greatly enhance your model's performance. If you found this video helpful, please subscribe for more insights, and don't forget to share your experiences in the comments.